I need to study right now, but I don't know how to start. Hmm, okay, I'll start first in the mathematics. Hi Shaina, what are you doing? I'm studying for our lessons chapter 5, lesson 3, which is simple linear regression analysis. Can I join? I also want to review. Sure. Or we can search the lesson on the internet.
Hi guys, welcome. So our topic for today is chapter 5, lesson 3, which is the simple linear regression analysis.
Objectives: understand simple linear regression analysis. How to use regression analysis to predict the value of a dependent variable based on an independent variable. To make inference about the slope and correlation coefficient.
A statistical technique called simple linear regression enables us to analyze and explore relationships between two continuous quantitative variables. The idea and the fundamental techniques of simple linear regression are covered in this session.
Regression analysis is a reliable statistical method of estimating how a response variable depends to one or more predictors. So we use regression analysis if we want to estimate the possible effect of independent variable to dependent variable. So the predictor is the independent variable while a response variable is a dependent variable.
So if we're going to plot it using scatterplot diagram, this will be the gas price, our x, the independent variable, and vegetable price will be our y or our dependent variable. So if we plot it and we can see that the gas price increases and we can see that the scatter plot form this kind of pattern, then it's possible that there is a relationship between the two variables.
One variable, denoted, is regarded as the predictor, explanatory, or independent variable. The other variable, denoted, is regarded as the response, outcome, or dependent variable. Because the other terms are used less frequently today, we'll use the predictor and response terms to refer to the variables encountered in this course. The other terms are mentioned only to make you aware of them when you encounter them. Simple linear regression gets its adjective simple because it concerns the study of only one predictor variable.
We commonly use correlational coefficient to determine the relationship, but it shouldn't stop there. After we know the relationship between the two variables, and if you want to know the effect of independent variable to dependent variable, we can use regression analysis.
Regression line. Regression line is used to model the relationship of the variables. The term line explains the possible best line of fit. It means the linear pattern is what we estimate in the regression, so we can call it regression line.
So for regression equation, it is in the form of slope-intercept. Y prime is our dependent variable, x is the independent variable, k is the intercept, and b is the coefficient for the independent variable.
So this is the formula that we're going to use if we want to know the value of A and B.
Why do we need equation in regression analysis? It's because we need to estimate the predicting capability of the independent variable. And if we want to predict the possible dependent variable given the independent variable value, then we can use this regression equation.
Characteristics of the regression line. When B is greater than O, Y increases as X increases. In this case, we can say that Y is directly or positively related to X. So as you can see on the scatter plot, that is the positive linear relationship.
Another characteristic of the regression line is when B is less than 0. Y decreases as X increases. In this case, we say that Y is inversely or negatively related to X. As you can see on the scatter plot, that is the negative linear relationship.
When b is equal to 0, y is constant and is equal to y-intercept a. This implies that there is no change in y, whatever x value is. So as you can see in the scatter plot, the points are scattered and it means that there is no relationship.
So the formula for the regression line is y prime equals a plus bx. A is called the y-intercept of the line and b is the slope of the line called regression of y per unit change in x. So the line that describes the statistical relationship between x and y is called the regression line. So it is the straight line that attempts to predict the relationship between points, also known as line of the best fit. So the regression line gives an estimate of the mean value of y denoted by y prime given the value of x. So hence, the equation of regression line is y prime is equal to a plus b times x.
So to solve for b, we're going to use the formula sum of square of xy over the sum of x. And for a, that is mean of y minus b times the mean of x. So in order to solve the sum of xy, that is summation of xy times the quantity of x times quantity of summation of y over n.
And to solve for the summation of square of x, that is the summation of x squared minus quantity summation of x squared over n. And take note, round the values of a and b to 3 decimal places. So I have here our conceptual framework, that is the data management tools. Below is a simple linear regression, and it consists of the 3 types of relationship, which is the positive linear relationship, negative linear relationship, and no relationship.